Hello, and welcome to J by Joe Pettit and John Gum. Sorry, this is my second time recording this. I had problems with audio the first time. So welcome to J by John Gum and Joe Pettit. About our language. So if you're familiar with C or C++, J is exactly what it sounds like. There is no memory management, there are no arrays, there are no strings. It is minus at its best. But our language is statically typed, so types cannot change. If you declare x to be a number, x cannot later become a Boolean or a string. The fun part is they do not need to be specified at compile time or runtime. So you can just declare x equals 4, and that's quite all right. Our compiler, similar to OCaml, will just infer it. Our language is compiled. Since our target language is Java, we opted for a language that is compiled as well. There is no live interpreter environment. We use block scoping, so if you declare a variable x within an if statement, later on after the if statement has closed, you cannot use that same variable x. You can declare another variable x within another if statement, and that works just fine. So our development process. We spent a good portion of the first couple weeks just testing and seeing if our translation languages would be viable for the project. After we decided they would be, we did like a high level overview and just kind of got like a design in place. We decided to go with Bash, Java, and Prolog. I know it sounds a little bit weird, but we'll talk about it in the next slide. We use GitHub for our version control and just keeping track of different features and able to like collaborate with each other without interfering with each other's code and keeping main as like a good viable branch. Here's a overview of our program. So like I mentioned, we use Bash, Java, and Prolog. Bash is kind of just a glue that keeps everything together. So Bash is our entry point. You're going to use Bash to send in the flags and any command line arguments and the file name. Java will do like an initial code check and then converts the file into a Prolog list. Java will then do a Bash call and we'll initialize that Bash call, initializes a Prolog script that calls a command that doesn't shorten its output, and then it will give that list from Java to Prolog. Java then captures that output from Bash and parses the output it gets. So Prolog just pretty much makes a syntax tree and then gives it to Java. Java then takes that syntax tree and makes a bunch of classes that are one-to-one with the tokens. Here are some of the challenges. So using Prolog created a lot of unforeseen issues. So capital letters aren't allowed in Prolog, they're variables. So using underscore, numbers, capital letters in a string or anything, it created some issues. So our programming language is case insensitive. So if you declare capital X to be 4 and then print lowercase x, that is perfectly valid. Also checking for failure is a little bit weird. Instead of describing all types of failure in Prolog, we ended up using a bit of a hybrid situation of Java and Prolog to validate the syntax. Calling Prolog from a Bash script or Java program, if the output is too long from Prolog, it will just shorten the output. So figuring out how to do long enough, how to get the whole command back, and then how to have Java capture the Bash script output was a little bit challenging. And then if you add like char onto all of it, it gets even messier. So there is a regular zip folder that runs on both of our local machines, Windows and Linux. And then there will be a zip folder that works on Lectura. For whatever reason, Lectura the scripts have to be different. So after writing some of our design choices, we decided you don't have to specify num string. We wanted our programming language to be very light, very syntax, not very syntax heavy. So you'll see it in a minute, but here are some of the things we decided on for like error messages. We added line numbers and seeing what was wrong after trying to write a couple programs. We realized how helpful that would be. And then after trying to write FizzBuzz with just if statements without an else or without an else if, it was quite difficult. So we added both else and else ifs into our language. So before I go into the little language example, here are just some things to remember. Parentheses are optional. Types are always optional. Make sure you have an end statement if you do like an if for a while. That's the one thing I noticed I was doing a lot. Double quotes are needed for strings. Any escape character used for Java for a string will work in our language. So \n adds a new line. If you type print, it's like Python, you automatically get a new line. So if you want 2 of them, if you do hello world \n, you will get 2 new line characters. So yeah, let's go to the code example. All right, so here is a code example of our language for FizzBuzz. But before we go into that, I just want to give a high-level overview of the language. So here's our prologue script, because I'm sure that's what most people are curious about. This is what the prologue looks like. It's pretty much just like a one-to-one what you would imagine from our syntax documentation. But we also included a J- syntax just text document. It's also in the README, but if you want something handy, it's right here. As I mentioned, our bash scripts were a little bit weird. So here's like a Lectura thing. There will be a folder for Lectura, but for whatever reason, if you're having problems with those, how to make them executable, how to remove the /R from in case they get caught from my Windows machine. And then here is all the command line arguments you can send in. All right, and then one last thing. We do have reserved keywords. So all the Java reserved keywords for obvious reasons, but then we have our own. So these words cannot be used as variable names. So n, bool, num, not, true, false. But yes, these words cannot be used. All right, so here's how you run a program in our language, or let's look at FizzBuzz. So here's a print statement. Like I mentioned, quote parentheses are optional. So down here we don't use them, up here we do. For strings, double quotes are always required. Here is a number being declared, x equals 0. Here's our while loop. The comparator operator, so less than or equal to, not equal to, double equals from C or C++ are all what you're used to. Our math operators have a little bit of a twist on them. You can use the little 3-letter acronym for add, sub, mul, div, mod, and that will do the same as using the regular character that you're used to, and we also include those. And then here is FizzBuzz. We have if, or in the while loop, we have if and else. So those are very helpful. And then we also have if and elf. Elf is similar to like an else if statement that you're used to in other languages, and it will run. To run the program, you call the JMM J-, script, and then here are what these flags do. So -J will give you the Java output, -T will show you the syntax tree, -P will show you the prologue, raw prologue output, -A is for command line arguments. These can be in whatever order. You can put as many or as little as you want, and then the file name. If the file does not include command line arguments, it's fine to include them. If it needs it, you're going to get a Java error if you send it in without command line arguments. All right, so here is the output. Here is the raw prologue output. You can kind of see what we do for our strings, how we tokenize them and send them into prologue. Java will then take this and match it back out. Here is our syntax tree with everything parsed out. And then here is the Java code, and then it will actually run the Java code for you. Cool. The next program I want to show you is command line arguments. So for a command line argument, $sign and the corresponding numeric value. So 0 is programming first, and then 1 would be the second. So in this example, we should get 1 and 2 back as our command line arguments that we passed in. Yep, you can see those print out right there. Here's Fibonacci. We thought that one would be pretty cool. And this one doesn't really show anything all that extra that I haven't shown before. Math printing does though. You can print math statements or Booleans. So it will evaluate x less than 4. It will print all these fun characters. To do a backslash, you need the double backslash for the escape character. And that, I believe, oh, one last thing, we do have comments in our language. Under the fails, there are comments. So if you use the pound or hash symbol, it's a comment and it is ignored by your language. It does not get translated to a Java comment. It will just be a comment. And anything you write gets sent to this Java minus.java file, and that's what actually runs. So yeah, if you're writing code in our language, I think that's about all you need. The rest of the video is really just going to be me going over the failed test scripts. So I hope you have a great day. For the TAs who are still here, here is some of our, or here are all of our fails. So here an else statement was declared without an if statement. So else should not work. All right, here we have else. So a double else, they, no elf, just an else, and that will return an error message with the line number. These will all have like corresponding line numbers and a detailed message. Here's an if statement with no end. Here is a lonely end statement with no corresponding while or if statement. Here are missing quotation marks, so don't want to do that. It will only print out the first 20 characters, so if you have a long string, we figure 20 would be about good enough to show where the error was. Here is an out of scope issue where J was declared within the if statement and then tried to call in a different code block after if was closed. Oh, I did not mean to do that one. There we go. J is not in scope. Here we forgot to close our parentheses on this math expression. And then here we did not open our parentheses, but only close them. All right, here's a reassignment failure. X was declared to be a number, but was then attempted to be reassigned to a string. It will fail for any variation of this. Here's an unknown error. So because we're using Java and Prolog, there was no real good way to, if you almost match something. So instead, if it's out, if it just cannot read what you're trying to do, it will just say that there's an unknown error. So Prolog wasn't able to determine, Java wasn't able to determine. And then trying to use a variable that was not initialized. This is similar to out of scope, but we also wanted to demonstrate that y was not ever declared, but it's being used in a math function. It's not just being used in an assignment or a print. If this were compounded in multiple parentheses, it would still catch. And then while no end, similar to if no end, there's just no end statement. I do want to point out all of our tests do actually have a corresponding test case with the command that will run all of them, but since it didn't, the direction said we had to demonstrate all of them. I went through them one by one, but here is all the tests just running. If you want to make your own test, you can put it into this folder. and it will, and with the output file, same name, just .out, it will automatically find all of them and check it. So yes, that is, I believe, all that we had for J minus minus. Thanks so much for hanging out and sticking around. Hope you have a great rest of your day.